All right, in this problem we're asked to calculate the percent gallium in a sample. To do that, we need to know the mass of gallium in the sample, and we need to know the mass of the sample. Looking over the information given, we see that we have the mass of the sample. Okay, here's the mass of the sample. Now we go back to the statement of the question to figure out how we can get the mass of gallium. Well, what they give us in the sample is the mass of AgBr that was precipitated from this sample. So we can go from grams of the silver bromide, convert to moles, and then we can relate the moles of silver bromide to the moles of gallium bromide. Then the moles of gallium, and then finally to the grams of gallium that's contained in that sample. All right, so let's do that. So we have 0.259 grams of silver bromide. We can use the formula weight to get to moles. Then we can relate moles of silver bromide to gallium bromide. We see that we need 3 moles of AgBr to relate to a mole of GaBr3. Then we see that there's a 1-to-1 mole ratio between that salt and elemental gallium. And then we can just multiply by the atomic weight. All right, so let's look at our units to see if we've set this up correctly. Grams to moles of silver bromide, to moles of gallium bromide, to moles of gallium. Okay, grams, we look good. So if we chunk all these numbers into our calculator, we would see that we have 0.032056 grams of gallium. Now that we know our mass of gallium, we can plug it into our initial equation and get our answer. Okay, finally we can consider our significant figures. Here we have 3, this is 5, this is exact, so it does not impact sig figs. Same reason this does not, 4 sig figs. So our initial mass of gallium is only good to 3 sig figs. As usual, we do not round until we get to the final answer.